Welcome to the Explainer. Today, we're going to do something pretty cool. We're going to build an entire world of information, completely from the ground up, starting with just one single raw fact.
So, let's start with a really basic question. When you strip everything away, all the context, all the organization, what do you call those fundamental building blocks of information?
And the answer is data. This is the raw material of our digital universe. We're talking individual names, numbers, dates, you name it. But by itself, a single piece of data, let's say the number 40,000, doesn't really have a story. Is it a salary, a zip code, a population? Who knows? It's just raw material waiting to be shaped.
To really get this, imagine all the knowledge in the world just thrown onto a giant library floor. Every single fact is there somewhere, but trying to find one specific thing or figuring out how two facts connect, it would be pretty much impossible. Just chaos, right? Well, that's the challenge of raw, unstructured data.
So, how do we fix this messy library floor situation? We can't just start picking up books at random. The first and most crucial step is to create a blueprint, a solid plan for how we're going to organize all this raw data into something that actually makes sense. In the database world, this blueprint has a name. It's called a schema. Think of it as the set of rules. It defines exactly what our data looks like, what it all means, and how different pieces of data can relate to each other. It's the architectural plan for our entire information structure.
And this is what one of those blueprints might look like. It's called an entity relationship diagram. Now, I know what you're thinking, it looks super complex, but the idea behind it is actually pretty simple. An entity is just a thing we want to keep track of, like an employee or a department. And the diagram just maps out the relationships between them, showing how they're all connected.
So let's bring it back to our library analogy. This diagram, it's basically the Dewey Decimal System for our data. It's the master plan that makes sure every single fact has its own specific, logical, and predictable place on the shelf. No more chaos.
Okay, so our library is perfectly organized now. The books are on the shelves, the catalog is all filled out. So how do we actually ask for a specific book or a piece of information?
Well, this is what you get from all that careful design. A simple, clean table of employee data. You see, each row is an employee, and each column is a specific fact about them, all organized perfectly according to the rules we set up in our schema.
Now, to ask our organized data a question, we use a special language. The most common one is SQL, which stands for Structured Query Language. This statement here isn't scary code. It's just a very direct command. It's basically saying, hey, from that employee table, show me the first name and last name of every single employee whose salary is more than 40,000.
And boom, just like that, the database gives us exactly what we asked for. Nothing more, nothing less. And that is the real power of a well-designed database. You can ask these incredibly specific questions and get precise, lightning-fast answers.
This system, the strict blueprint and the specific query language, it works beautifully. But what happens when the amount of data we're dealing with isn't just a few employee records? What happens when it gets astronomically, unimaginably huge?
Just think about this for a second. Way back in 2010, companies were already storing over 13 exabytes of data, and an exabyte is a billion gigabytes. That is such a mind-boggling amount of information that our neat and tidy library model starts to, strain at the seams.
And that brings us to the modern era of big data. You've probably heard the term. It's really about data sets that are just massive in volume, coming in at high velocity and have a huge variety. They're so big and complex that the traditional database tools just can't keep up.
This huge challenge led to a brand new solution. So on one side, you have our traditional SQL databases. They need that strict blueprint, right? Like our pre-planned library catalog. Perfect for highly structured, consistent data. But on the other side, you have NoSQL. Its structure is flexible. It's more like a giant, searchable pile of documents. This whole approach was born out of necessity for web giants. Think social media or e-commerce, where handling massive, messy data at incredible speed is way more important than having perfect organization up front.
Okay, so we've looked at the data, the blueprints, and the incredible scale of it all. But what about the people? Who are the folks that actually build, maintain, and use these amazing systems? The world of databases is kind of like a bustling city. You've got the database designers, they're the city architects, drawing up the blueprints to make sure everything works efficiently. Then you have the end users. These are the everyday citizens. Think of a bank teller checking an account or an airline agent booking a ticket. Their jobs completely depend on having fast, reliable access to this data.
And finally, you have the casual end users. I like to think of them as tourists. They might be executives running a quick report or an analyst looking for a new trend, just dipping into the data in less predictable ways. But every single one of them relies on the work of those architects. So, let's wrap this up. We started with a single, meaningless fact. We learned how to give it structure with a schema, how to ask it questions with a query, and then how to scale it all up to handle the big data that powers our entire modern world. As our real world becomes more and more built on this foundation of data, understanding its structure and scale has never been more important. Which brings us to a final thought. If data really is the new foundation for everything, who do you think should be its architect?